Hey guys, welcome back to another video. And today I'm going to be explaining my rocket altitude simulator version 1. So this is version 1, so it's pretty basic and it's for beginners because it uses all beginner concepts like libraries, variables, print text, and basic arithmetic. So it is basic, but I would suggest all of you guys start with this and hear the explanation of it so that you guys can further actually understand how the project is going to go. And there are multiple versions. I've already done 3 versions. This is version 1. I've already posted the 2 versions on my GitHub. I've not made the videos of those. I will be making them very soon. So if you have any questions about anything in this code, even if you have questions outside this code, you can always leave it in the comment section. I will answer them as soon as possible. And even if you have something completely random about Python, which is obviously in my skill level, I will answer it and I will make a video about it if it requires a video to explain it, and if a lot of people have the same question. So let me show you the rocket altitude simulator. So if I go right here, I'm gonna go right here. It's not this, by the way, it's this one that's loading up right now. So right here is a rocket altitude simulator. This is basically 3 columns, which is going to show me data based on the time my rocket has been flying or its launch. So at 0 seconds, the altitude is obviously 0 and the velocity is obviously 0. At maybe 15 seconds or 17 seconds, the altitude is 2,890 meters and the velocity is 340 meters per second. So this is basically the rocket altitude simulator version 1 that you are going to be coding today with me, and which is in my GitHub. So again, I keep reiterating this, but if you have any questions about anything that's in my skill level and about this project, please put in the comments. I will answer them. I will be glad to make a video or explain them. So let's start with the first line and arguably probably one of the most important. This is the import time, which is basically a library, and that's how you import libraries in Python when it's already built in. If it's not built into Python, then you have to go into terminal and say pip install all that. But I'll not get into that now. I'll go maybe in another video if I do need it. But right now we just have to do import time, and time is an extremely important factor in this version 1 of the project because you have a lot of variables which include time. So if you look at line 5 and 6, which the red dot is hovering over, so line 5 and 6 is extremely important because these are variables which include time, as you can see the seconds, and those variables are important. So obviously some lines which do include those variables will be even more important. So as I said, this time library needs to be installed, and that's the first step you should do when you're making this Python project. And that's a good reminder with every single project that you make on Python, is that you should first think about what libraries do I need for this project, and then further go into it. So last video, in my object tracking version 1 video, the first thing I talk about in every project I will do is the libraries, because it's arguably one of the most important. It's probably like the crumbly part of a cheesecake. It's like the most important part. So it's the foundation. So obviously import this time, and that's basically the libraries that you're gonna need for version 1. So let's go into the rocket parameters. So as you can see, these are just basically variables. I don't think this needs much explanation. You might be wondering why the acceleration is 20 and all that. The only reason why the acceleration is 20 is because it's a constant factor. So your acceleration is going to be constant, which is not really true. That's not how Earth works. And as I said, this is version 1, so it's only accounting for Earth. So even version 2 only is going to account for Earth, I think. But it's that's not how Earth works, right? Like, the acceleration is never constant. It's going to be there's airspeed, there's gravity. But right now, we're not having gravity. Version 2 will be adding Earth's gravity into this. But acceleration, I just added 20 as a random number. You can change it as much as you want to just see how the data changes or something. But as I said, this is just a basic constant acceleration that we're going to be using just to test out. So this is basically the variables. I don't think this needs much explanation. And if you do need some things, I will remake a video, or as I said, I'll put in the description or something if you have questions. So I'm sorry for reiterating that so much because I feel like I really want y'all to like really understand this. So if you do have questions, please comment it. I have all the time in the world. I will answer them. So let's go into line 8 and 9. So this is very simple, but it's basically a print. So print, if you actually ever add a print onto something, you just need to type print. You need to make the brackets, your little quotation marks, and whatever words you want to make. So that's how you basically add a print onto it, and that's how you print stuff on terminal. But right here is we're just adding rocket altitude simulator. I put some nice emojis just to make it look better. And this line is just to separate the title from the actual data. So now once you're done with all that, the making it look good and stuff, and all your maybe adding more text if you'd like. So then you gotta go to line 12. So right here, where it says while time elapsed, it has to be 20. So that's basically saying if you actually saw the project, which I'll pull up again. I'll run this again, which is right now running. It stops at 20 seconds exact. So you can actually make this 30, 40, 50, 60, whatever you want, and it will change that. I just added 20 seconds, so that's basically saying how long will the simulation run for. Now it's where the math and the physics part comes to. Now, don't get scared when I say physics. This is extremely simple physics. It's just probably multiplication and just basic math. So now we're going to calculate the altitude. So to calculate altitude, you have to always talk about your altitude times your acceleration plus the time that has been, or your time that has been elapsed, squared. So this is basically the equation. And if you didn't understand that, and you might be wondering, oh, how would I know that? Just ask ChatGPT or ask Google for the equation, and that's how you would code it. So it's just you're just making simple equations. So altitude and velocity, these are the two equations to calculate these two things. As I said, this is not going to be a brief explanation about every single concept in these equations. I'm just explaining them so like you can really understand how the code is set up together. So these are very simple if you actually look at it from a bird's eye view. But when you look at line 20 to 22, I believe, that's where it looks a little like, whoa, what is that? And don't worry, it's actually extremely simple. All this is just formatting. Yeah, you heard right. Formatting. So here, if you actually look at the program, I'll just run it once more. You can see time, altitude, velocity. You should remember those now. I'll just explain them in a second. Time, altitude, velocity. Let me close out of this. And time, altitude, velocity. That's literally it. Time, altitude, velocity. It's just showing those columns. And what is that F, you may ask? That's an F string. It's a little more complex and I can't really explain in this short video I'm trying to make, so I will make it earlier, but it's basically an F string. You can research that on your own, or I will type it in the comments for you guys to read. This is an F string, and what you might be wondering, what the heck are these numbers here? That's just telling, oh, do you want me to put in the decimals, or do you want to put in commas, like 600, comma, 1000, or do you want me to put 6.0, like that stuff? That's basically formatting of it. And finally, this part is another equation, guys. I don't want to explain these equations too much because it's basic math. And I feel like if you just do a quick Google, these equations are ready for you guys to use. So I'm going to explain this part. So when I was actually showing this to some people, line 26 confused them a little because, like, what is time dot sleep 0.2? If you really notice it, it's not when I run the program, it's just not popping up all of a sudden. It's having a gradual progression. There's nothing really more than the aesthetics part of it. I just like having it where it looks like it's actually loading up. That's basically it, because the computer can do it much faster than 0.2 seconds. It's just taking 0.2 seconds for every interval. So from 0 to 1, it's 0.2, 1 to 0, 0.2, like that. So from time, when the time is 0, the program will stop for 0.2 seconds and then display for what happens in the second. That's basically what it is. So it's just giving a little pause, and I'll just run it once more, guys. So as you can see, there's a slight pause, and it looks like it's loading. This is just an aesthetics part of it. You don't need to add this. I liked it, so I wanted to add it. But that's basically the Rocket Altitude Simulator, guys, version 1. If you're a beginner, this is a really good project, as I said, and if you have any questions, drop it in the comment section and check my GitHub down below. And I will make videos about my other versions very soon. This is just version 1, and version 2 is going to be much more exciting with more parameters and much more complex, and it'll give you some. It'll make you feel proud. Let's just say that's going to make you feel happy and how much user interactiveness is going to be there. I've added a lot of things in version 2 and version 3. So be sure to check those out once I do make the videos. And again, I'll link the GitHub in my description as always. I'll answer your questions. I'll make a video if the questions are if it's gonna take too long to answer the questions, all that stuff. So I'll see you in the next one, guys. And the next one's probably gonna be Rocket Simulator version 2, and this is version 1. So thank you, and I'll see you next time.